Hey everyone, welcome back to my YouTube channel. Myself Spencer. As you all know, I'm Spen in Sri Intellectual College Engineering, Bangalore. I'm a third sem student. To- Today, let's discuss the topic F distribution from the subject maths of which has the postcode of BCS 301. F distribution. First, let's go to the agenda of today's topic. First, let's know what is F distribution, its definition and formula, its characteristics, application of distribution, steps for F-test means the hypothesis to solve the F distribution, and an example problem, the graphical representation of F distribution and its advantages and limitations. First, let's know what is F distribution. The F distribution is a continuous probability distribution used to compare two variances or test hypotheses about multiple means. Its key applications are ANOVA, analysis of variance, and their test in regression models, arises when the ratio of two independent squared variables divided by the degree of freedom is analyzed. Now let's know this definition and formula. The F distribution it is a continuous probability distribution that arises when comparing two variances. It's defined as a ratio of two independent or distributed variables divided by the respective degree of freedom. Here, the formula is F equals to S1 squared by V1, the whole divided by S2 squared by V2. Here, S1 squared and S2 squared, they are the variances of the two samples, whereas the V1 and V2, they are the degree of freedom of two samples. Now let's go to the characteristics of F distribution. The F distribution is always non-negative because variances cannot be negative. Here it says that the variances V1 and V2 they cannot be now they cannot be negative. And the shape it has a skew to the right, especially when degree of freedom is small. When the degree of freedom is small, it has a skewed shape towards the right and it approaches a normal distribution V1 and V2 increases. As V1 and V2 increases, it approaches towards a normal distribution. It depends upon two parameters, namely numerator and denominator. While numerator consists of V1 and denominator consists of V2. They are the degree of freedoms. Now let's go to the application of distribution. Listing equality of variance. Determine if two databases have the same variability. Example, comparing tolerances in manufacturing processes. ANOVA, analysis of variance. Analysis different in the means of multiple use. There are different types of ANOVA, like one-way ANOVA and two-way ANOVA. Example, comparing performance across different teaching types. Regression analysis. Test if a regression model fits the data better than a baseline. Example, validating predictive models in quality control. Hypothesis testing. The test the null hypothesis X0 of equality in variances. Now let's know how to solve the F distribution hypothesis. A null hypothesis is defined as by sigma 1 square is sigma 1 square equals to sigma 2 square. That in that case, like variances are equal, then it is known as null hypothesis. Null hypothesis is represented by X zero. Alternative hypothesis. Here, the variances are different and they should not be equal to each other. For example, sigma 1 square not equal to sigma 2 square. Here, the variances are different. Therefore, it's known as alternative hypothesis. The alternative hypothesis is represented by x1. The procedure is first we need to compute sample variability. Those are s1 square and 2 square. And we need to calculate the f statistic. Where from the formula we know that f equals s1 square by s2 square. This where the s1 square should be greater than S2 square. Here, we need to use DF table to find the critical value of V1 and V2 and significance level. And we need to compare the critical value if F is greater than F. If F is greater than the critical value of F, then the hypothesis is rejected. Here comes an example problem. Two machines produce with the same following variances. Mission 1, H1 square equals 36, N1 equals 20, mission 2, 2 square equals 24, and N2 equals 30. And test of variance are equal to sigma equals 0.05. First, we will calculate F. As known formula, F equals to H1 square by H2 square, 36 by 24, equals to 1.5. Now, as you know, the degree of freedom formula is V1 equals N1 minus 1, which equals to 19, whereas V2 equals to N2 minus 1, that is 29. 30 minus 1 is 29. And we need to find the F critical table for 0.05. V1 equals to 19 and V2 equals to 29. We will get the value as 2.1. As it is less than the critical value, we can accept it. Now, let's know the advantages and limitations. First comes the advantage. Simple and effective for comparing variances used in varieties statistical modeling among the regression, and its limitations are sensitive to deviations from normality in data, require independent and identical distributed samples. Thank you for watching.